Okay, please bear with us. We're having a couple of technical difficulties, but Ms. Chuka will be the one presenting for today. For those of you that are going to review for the Math 1324, there is a link on the chat that you can follow for that, and Mr. Sassi will go ahead and coordinate that presentation. Thank you.
Sorry guys, I have my mic muted. So today we're going to go over some problems for exam 1 review. And if you are enrolled in 1324, they just put a link for you so that you can go to another room which will basically focus on the 1324. If you're in 1314, then you can just stay here. And so we'll get started. At any time, if you have any questions, please let us know. And you can also make this presentation a little bit larger if you like by clicking on the magnifying glass, or you can also download the file by clicking this box with a down arrow. So the first thing we're going to do is we're going to look at how do we find the distance and the midpoint between 2 points. And so here they give us 2 points, 8, 4, and 8, negative 6. So we can label these as x1, y1, x2, y2. The distance formula is given by the square root of x2 minus x1 squared and y2 minus y1 squared. So if we plug in our numbers, x2 is 8, x1 is 8, and y2 is negative 6, and y1 is 4. So if we simplify, 8 minus 8 is 0, and negative 6 minus 4 is negative 10. 0 squared is 0, and negative 100 squared is negative 10 squared is going to be 100. So the square root of 100 is plus or minus 10, but since we're looking at a distance, then we don't consider the negative part of the result. Okay, so that's how we find a distance. The midpoint is given by x1 plus x2 divided by 2, y2 plus y1 divided by 2. So again, we plug in our numbers. So my x2 is 8, my x1 is 8, so 8 plus 8 divided by 2. And then y2 is negative 6 plus y1 is 4 divided by 2. We simplify. 8 plus 8 is 16 divided by 2. And negative 6 plus 4 is negative 2. Simplify some more, so we get 8, and then we have negative 1. So notice here that I have my parentheses because this is actually a point in our graph, right? So that is the distance and the midpoint. The next question is write the standard form of the equation of a circle with the given characteristics. So we have our center at negative 4, 2, and then our radius is 2. So what I what I like to do is I always like to have the formula that I'm working with. So here the standard form of a circle is x minus h squared plus y minus k squared is equal to r squared. The problem gives me the center. So my center, I'm going to call this h, is -4 and k is 2. And then my radius, they tell me is 2, so that's going to be my r. So I'm going to go ahead and substitute those values. So I have x minus h, which is -4, and y minus k, which is 2. And then my r is equal to 2. And then notice that I can simplify a little bit here. Negative, negative is positive. And then we have a negative will stay there. And 2 squared is 4. So this is our standard form of the equation of a circle given the center and the radius. Here they want us to find the center and the radius. So again, I also like to, again, write the standard form of a circle. And so what we're going to do is I'm going to write my equation below it. So notice here I have my x is my x. I have my minus sign is my minus sign. Therefore, my h is going to be 1. And then in this example, I have y is y. But I have my minus sign is not a minus sign here. It's a plus sign. So I need to kind of rewrite that a little bit. And so for the plus sign, I can rewrite it as negative or a minus sign times a negative, since negative and negative will become that positive. So I can take my center. So my h would be 1 and my k would be -2. And then I can set, so here's my h and my k is 1 and -2. And the shortcut, I mean, I think it's, people look at it as a shortcut. If you have a negative, -1 here, then you're going to have a positive. If you have a +2, then you'll have a negative. But the reason we can do that is because of what I just illustrated here. Now we need to find our radius. So for the radius, we can set r squared is equal to 25. If we take the square root on both sides, then we get r is equal to 5. And so our radius is going to be 5. Okay, so now what if we wanted to graph this? So to graph, we need to find the center. So since I have a -1, I'm going to have 1. And since I have a +2, I'm going to have a -2. My radius is the square root of this number. So the square root of 25 is going to be 5. And to graph, you want to plot the center to help us here. So my center is -1 and 2. From this center, you want to use the radius. The radius is going to go up 5, to the left 5, down 5, and to the right 5. So if we plot that point, then we can see it here. We went up 5, 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, and so on. So now I can sketch my center, and this is going to be my center. Okay. Find any intercepts and test for symmetry with respect to both axes and the origin. So here, to find the x-intercept, we let y equal to 0 and solve for x. So here's my 0, and I'm going to subtract 1 on both sides. And then I'm going to go ahead and do my subtraction. And then to simplify, we'll divide by -4. And so we get x is equal to 1/4. So that's my x-intercept. And then my y-intercept is y equals -4 times 0 plus 1. So we get y times 0 plus 1 is going to be 1. So that's going to be your y-intercept. Now the symmetry, if you were to graph this line, then we can see that there's no symmetry. If you don't want to graph it or your instructor is asking for your work, then we would have to do this algebraically. So to do the x-axis symmetry, we're going to be changing the y value. So instead of the y, we're going to change its sign. So now it will be -y, y. And so here's my original equation. I'm going to replace the y with a negative y. And so it looks like this. Then you want to solve for y. So if I divide by negative 1 on both sides, then I get y is equal to negative 4x divided by negative 1 plus 1 divided by negative 1, which is y equals 4x minus 1. So what you want to do is compare this result with the original equation. If they are the same, then we know that they're symmetric. But notice that my result here is not the same as my original, so therefore the equation has no x-axis symmetry. Mr. Carizales, can you do the next two really quick? I need to do something really quick.
Yes, ma'am. No, no worries. Okay, so let's go ahead and find the y-axis symmetry. So for the y-axis symmetry, okay, just as the formula says for us to do, we're going to get the equation y is equal to minus 4x plus 1. But now what we're going to do is we're going to replace the negative 1 with the x, right? So we'll go and we have, or the negative x, so we have a minus 4 with a minus x. So if we distribute the negative with the negative, and multiply the 4 times the x, we're going to get a positive y is equal to 4x plus 1. This is not the exact same equation, so hence this one does not have y-axis symmetry as well. So then if we try the origin symmetry for an equation to have origin symmetry, we would replace, we're mixing actually the negative symbol. We would replace both of them. We would replace both the x and the y with a negative. Okay, here it is correctly. So we would replace the negative with the negative y with a y, and then the negative x with the x. And if we simplify this, we would end up with a negative y is equal to 4x plus 1. Now we can distribute the negative to the other side, but it still would not give us the same equation. If we see here, we do have the negative slope, but the intercept now says it's at negative 1. So hence, this equation does not have either x, y, or origin symmetry. Okay. All right, so let's look at these equations here. Determine whether the equation represents y as a function of x. So we know, since this is review, we know that a function is a function if every input corresponds to only one y value. Okay, so if we're looking at these equations here, we start with this one and we're to graph it. Okay, by now we know that this graph would be represented as a line. Now again, to review, one way we can test to see if we were given the graph to test to see if this was a function, we would perform our imaginary or our vertical line test, right? We do an imaginary vertical line, and if this line crosses our graph only once, then it is a function again, and we're testing that that definition of a function, that every x value corresponds to only one value. So this first one, it is a function. If we look at the second one, this is going to produce our graph. This is called a parabola. And again, if I perform my vertical line test, my imaginary vertical line will only cross my graph only once. So hence, it is a function. And then if we look at this third equation, okay, the one with the square root, this graph will produce this curved line here. So then again, if I perform my imaginary vertical line, my line will only cross my graph once, so hence it is a function. And then the last one, the last one is going to produce a circle. So again, on this one, if I were to perform my vertical line test, it would fail. I have an x value that corresponds to a positive y value and a negative y value. So hence, this test fails. So hence, this equation is not a function. Okay. All right. So let's look at some more. Determine whether these equations represent y as a function of x. Let's look at the cubic. If we were to graph it, this is like an sort of like an S-looking wavy graph. Again, if I perform my vertical line test for this graph, it's going to pass, right? So then it is a function. And then if we look at this one, this one's a square, but it's a a parabola, but it's on its side, right? So if I were to solve it, just so to make it easier for you to see that, we're going to end up with two answers for my x. When I plug in x, the y value will produce as a positive 2, and the other will produce a negative 2. So again, this is not a function. And if we were to see the graph, it would be like a parabola on its side. And again, you would be able to see that our vertical line test fails. All right, so, oh, here it is. So this would be my graph. And again, this is what it represents. If I do my vertical line test, it's going to fail. Okay. All right, so let's look at this next example. Let's use the graph of f of x is equal to square root of x to write an equation for the function represented by each graph. Okay, so the first thing that we need to know is that that would be super helpful is if we know this graph here, which is called our parent function. Okay, this is our square root function, and the parent, its graph is like this. It starts at the origin here, and it's like this curve. Okay, so what I see, we had several transformations that go from our parent to the equation that they're giving us. Okay, so one of the things that I see here is that my graph got shifted 2 units to the left. Okay, so how would I represent that? So to represent that this graph got shifted 2 units to the left, I'm going to my parent function, I'm going to add 2. Now, we're saying we're moving to the left, but there's a plus 2. Wouldn't you move to the right? Well, think of it this way. You're solving for the intercept, right? So if I were to solve for the intercept, I have to move that 2 to the other side to solve for x. And that when I move it to the other side, I need to subtract 2 on both sides. Hence, my x-intercept is going to be negative 2. So that's why even though there's a plus, we are moving to the left. Now, let's see what else is happening to our graph. Our graph, we saw that it got shifted 1, 2, 3, 4, 5, 6, 7, 8 units down. Okay, so that is a transformation on my y-axis. I'm traveling down. So on that one, I have to go outside the radical, and I am going to subtract 8. This is what's going to represent my vertical shift. I'm going to go 8 units down. So this graph is represented by this function. F of x is equal to the square root of x plus 2 minus 8. Okay. All right. Let's look at this one. This one's interesting. This one looks like we have some weird things going on, but let's go step by step. So the first thing that I see here, if I always want to think about my parent function. Let me write my parent function. This is what the square root of x graph looks like. Okay, so if you see that there's quite a few differences. So let's start a transformation at a time. So the first thing that I see here, that my graph got shifted 2 units to the right this time. Okay, so what I first gonna do is let's look at the fact that it's backwards, right? So this one had a reflection. Okay, so we know that when I do the negative square root of x, it's going to reflect my graph on its x-axis. Okay, I can also do another reflection. I know that if I put the x as a negative, if I change the sign of the input, it's going to reflect it on the y-axis. So now you see that it has the same curve, right? Now the curve is going towards the left. Okay, so we had 2 transformations to do to make this curve turn to the left. Now we can do our other phase changes. So as I mentioned to you, we saw that this graph got shifted 2 units to the right. Okay, so we're going to subtract 2 on to my x, just as opposite before. The other one I was adding 2, so it shifted to the left. This one I'm subtracting 2, so it's shifting to the right. And then now it leads me to the last transformation. I see that my graph got shifted 5 units down, so I have to exit the radical, and I'm going to subtract that 5 on the outside. So this graph that was given originally for me is represented by this function. F of x is equal to negative square root of negative x minus 2 minus 5. Okay. All right, so let's look at another example. It says write equations of the lines through the given point that are parallel and perpendicular to the given line. So they give me an equation which is in standard form, and they also give me the point that they want my lines to go through. So I have two answers for this. So I need to answer two equations: a parallel equation to the given equation and a perpendicular equation to the given equation. So my first step, in order for me to know the parallel and perpendicular, I need to know the slope. We know that if two equations have the same slope, then they are parallel to each other. And if the equations, what I like to call opposite slopes in a particular way, then it's perpendicular. And I'll go over that right now. So the first thing that I need to do is I need to know what the slope of this given equation is in order for me to solve it. And then after that, what I'm going to use is my point slope formula to get my answer. So the first thing I'm going to do to this equation is solve for y, or in other words, convert it into its slope-intercept form. And so when I do that, I get y is equal to 4x minus 3 halves. Now, the minus 3 half, I don't care. This is just where it's crossing the y-axis. It's the b part, right? What I'm really interested in is the 4. It's the slope. So I know that the slope of this equation is 4. So if I want to come up with an equation that is parallel to this equation, I know that my equation has to have a slope of 4. So now again, what I'm going to do is I'm going to use my point slope formula to get that equation. I have everything I need now. I have the point and I have the slope to do that. So let's go ahead and just plug in. Okay. So let's substitute the values that we know. We have the y1 and x1 is the point that we want to go through, okay? And m again refers to our slope. So we have this. We have y minus 1 is equal to 4 times x minus 8. So our first thing we need to do is we need to distribute our 4. So when we do that, we're going to get 4x minus 32 on the right side. Then the last step that we have to do is we need to add 1 on both sides so we can solve for y. So when I do that, I'm going to get y is equal to, oops, double clicked it here. Y is equal to 4x minus 31, right? So minus 32 plus 1 is the minus 31. So this is the answer for the equation that is parallel to this given equation. See, it has the same slope. Now let's look at the perpendicular one. So again, to get the perpendicular slope, what I do is I take the reciprocal of this slope. So the reciprocal means that if I convert this into and let me write it so you can see it. If I write this into a fraction, which is what slope is, a rise over run, right? I take the reciprocal of this. I make the numerator become the denominator become the numerator. That gives me the 1/4. And opposite to a positive is a negative. So hence, the perpendicular slope that I want to use is this one. M is equal to negative 1/4. Now the next procedure is the same. All I have to do is replace the given information to my point slope formula and solve for y. So again, I'm going to distribute my negative 1/4, which is going to give me the negative 1/4 x times the negative 8 times the negative 1/4. Um, Give me 1 second, guys. Let me plug in my calculator. Give me my computer. Give me 1 second.
So I'll continue. So here, if we distribute the negative 1/4, we get negative 1/4 x, negative 1/4 times negative 8. And so if we multiply those together, then we can see that negative 8 times negative 1/4 is positive 2. And now we're going to add the 1 to the right side, or on both sides. And we end up with y equals negative 1/4 x plus 3. So this would be our equation for a line that's parallel to our given equation. So let's continue. Whenever we have, consider the following, we have f of 1 equals 7 and f of 0 equals 8. So here they want us to write the linear function of f given the values. Since they want us to write a linear function, in order to do that, we need to have a slope and at least 1 point. Okay, so we can think of this information, we can break it down as points. So here our 1 is representing x, our 7 is going to be representing y, and then the second point we have 0, and then we have the 8. So now we can find the slope using the slope formula. So we have 8 minus 7 divided by 0 minus 1. 8 minus 7 is 1, 0 minus 1 is negative 1. So our slope is negative 1. And now, if you notice here, our point 0.08 is a special point because it already tells us that this is our y-intercept. How do we know that it's the y-intercept? We know that because our x value is 0. So now we can just plug it into our equation. We can use the slope-intercept form, or we can use the point-slope form. Since we already know what the y-intercept is and we have the slope, then 8 is going to be b, and then our slope is negative 1. So my answer would be y equals negative x plus 8. Okay. Find the function value if possible. So here they want us to evaluate the function at x equals 1. So f of 1, what we want to do is anywhere we see an x, we're going to replace it with this value 1. Okay, so we're going to replace it with x with 1. So we're going to end up with f of 1 is equal to 3 times 1 minus 8. 3 times 1 is 3, and 3 minus 8 is negative 5. Let's try the next one. Now we're going to take everything in the parentheses, which is x plus 4, and anywhere that I see an x, I'm going to replace it with x plus 4. So here we get 3 times x plus 4 minus 8. We simplify, and we end up with 3x plus 3 times 4 is 12 minus 8. So that's going to give us 3x plus 4. Okay, let's try this one. So again, we're going to replace whatever's in the parentheses. We're going to replace it with every t that we see here. So we're going to have 5 times 2 squared minus 6 times 2 plus 4. 2 squared is 4 times 5 is going to give us 20. And 20 minus 12 plus 4 will then give us 12 as our final answer. Now we're going to replace the variable t with t minus 2. So anywhere I see a t, I'm going to replace it with t minus 2. So I get 5 times t minus 2 squared minus 6 times t minus 2 plus 4. So if we simplify, we can rewrite t minus 2 squared as t minus 2 times t minus 2. And we're going to go ahead and multiply those out. So t times t is t squared. T times negative 2 is negative 2t. And negative 2 times t is negative 2t. And negative 2 times negative 2 will be a positive 4. Let's go ahead and multiply everything in the parentheses by 5. So we get 5 times t squared is going to be 5t squared. T squared is going to be 5t squared. 5 times negative 4t is negative 20t. 5 times 4 is 20. And then we're going to combine like terms. So there's no other t squared, so I'm going to write 5t squared. Here I have a negative 20t plus a negative 6t is going to be negative 26t. And then I have 20 plus 12 is 32 plus 4 will give me 36. Okay, so now we're going to be subtracting these. So first we want to evaluate what g of t is. So we're going to replace every t with t. So that's just going to be itself. 5 times t squared is 5t squared. Negative 6 times t is negative 6t plus 4. So again, you can see that this right here is just the original function. And then our g of 2, if I plug in 2, we get 2 squared is 4. And then 5 times 4 is 20. Negative 6 times 2 is negative 12 plus 4. So that's going to give us 20 minus 12 is 8, and then plus 4 is going to be 12. So now that we know what g of t is and we know what g of 2 is, then we can subtract those values. Now I'm going to put them on this side. So g of t was 5t squared minus 6t plus 4 minus g of 2, which is going to be 12. Notice I put parentheses here, and I do that because sometimes you might have more than one term here, and we want to make sure that the minus sign is applied to everything in that parentheses. So if we simplify, 4 minus 12 will give us negative 8. Next, we're going to do they give us two functions, and we want to add f plus g of x. So first, we can rewrite it so that the way it's defined. So f plus g of x is f of x plus g of x. F of x is x plus 2. G of x is x minus 2. Combine your like terms, so x plus x is 2x, and 2 minus 2 is 0. So my answer is going to be 2x. If we subtract, again, f minus g of x is the same as f of x minus g of x. So I have x plus 2 for f of x minus, and notice my parentheses, minus g of x, which is x minus 2. So we're going to go ahead and distribute the negative. Negative times x is negative x. Negative times negative is positive 2. Combine your like terms, so x minus x is 0. 2 plus 2 is 4. And then the next one is multiplication. So that's f of x times g of x. So we get x plus 2 times x minus 2. So if we multiply, we get x times x squared. X times negative 2 is negative 2x. 2 times x is positive 2x. And 2 times negative 2 is negative 4. So we end up with x squared. This should be 0 and then minus 4. So this is not supposed to be here. Okay, let's try the f minus g. So if we're dividing here, we're going to have f of x is x plus 2 and g of x is x minus 2. I cannot simplify this any further, and so that's just going to be my answer. And we probably have a domain question. Yes. What is the domain of f divided by g of x? So if you notice here in our f divided by g of x, we have a fraction, and in the denominator, we have a variable. So there's going to be some restrictions that we cannot have for x as part of our domain. So to find those, we could visually see what number will cause our denominator to be 0, and that would be 2. But if you're not sure, then you can set the denominator equal to 0. So we would have x minus 2 is equal to 0, and that would be x is equal to 2. So here, what this is telling us is that the domain can be any real number except for 2. So it can be any negative number, so we represent that with negative infinity, all the way to the number 2, and then we use our symbol union from 2 to infinity. Okay, so here we have another one, f of g of x. If we multiply these together, we're going to have f of x, which is x plus 3, times g of x, which is x squared minus 2. So we're going to multiply both parentheses. So we get x times x squared is x cubed. X times negative 2 is negative 2x. 3 times x squared is 3x squared. And 3 times negative 2 is negative 6. Combine your like terms, so we have x cubed. We have a 3x squared, a negative 2x, and a minus 6. And that would be all that I can combine. So the next part is finding the composition. So here we have f composed with g, and that's what the little symbol means here. It's not multiplication, but composition. So one of the things that I like to do is rewrite it. So we're going to rewrite this as f of g of x. The second equation is what goes in the parentheses. And so now I can simplify. I can replace g of x. This is my g of x. I'm going to replace it with what they tell me it is, which is x minus 9. So next, we can take x minus 9, and we're going to replace x minus 9 for every x in the function f. And how do I know to do that? Because here I have my function f. So I'm going to take what is in here and plug it in for x. So we end up with, for this x, we end up with x minus 9, and then we have a plus 4, combine like terms, so we get x minus 5. Our next one is g composed with f. So notice my second function is what goes inside. F of x is x plus 4, so I replace that with x plus 4. And then I'm going to take this information and I'm going to plug it in for my function g. So I get x plus 4 minus 9, and that gives me x minus 5. So here, they're both the same, but that doesn't happen all the time. This was just a coincidence. Here we have g composed of g. So again, if we rewrite it, we get g of x. So g of x is x minus 9. So now we're going to take this x minus 9 and plug it in for every x in g. So we get x minus 9 minus 9. So we end up with x minus 18. So for the next one, we have f composed of g. So if I rewrite it, we get f of g of x. What is g of x? X minus 1. So we're going to replace g of x with x minus 1. Now it's telling me to go to function f, and wherever I see an x, I'm going to replace it with x minus 1. So here I have an x, so I'm going to put x minus 1 squared. So that's this information. And then I'm going to simplify, so I can rewrite x minus 1 squared as x minus 1 times x minus 1. So x times x is x squared. X times negative 1 is negative x. Negative 1 times x is negative x. And negative 1 times negative 1 is positive 1. So negative negative x would be a negative 2x plus 1. G composed of f. So an f of x is x squared. Wherever you see an x for the function g, we're going to replace it with x squared. So here for this x, I'm going to replace it with x squared minus 1. And then I cannot combine these, so that would be my answer. And the last one, we get g composed of g of x. So g of x is x minus 1. We're going to take all of this, plug it in for x here. So we get x minus 1 minus 1, which comes out to x minus 2. The next question is, does the function have an inverse? So the first thing you want to make sure is that the graph here is a function. I mean, they tell us it's a function, but sometimes they don't say it's a function. But if you notice, in order to decide if it's a function, we were using the vertical line test, right? We were drawing a vertical line, and if it touches the graph only in one place, then we said it was a function. But now, since it's asking us for the inverse, does a function have an inverse? In order to decide if it has an inverse, instead of a vertical line, we're going to draw a horizontal line through the graph. And if it touches in one place, then it's going to be a one-to-one function, which means that it's going to have an inverse. Okay, so this function has an inverse. And so everything I just said is on this slide here. So again, we use the horizontal line test. And let's continue. So here, determine whether the function has an inverse. So if it does, then find the inverse. So the first thing you want to do is we want to go ahead and ask ourselves, what type of function is this? If you were to graph it, would it be a circle? Would it be a parabola? Would it be a line? What type of function is it going to be? And so we know that this is going to be a line. How do I know that? The largest exponent for x is 1, so that makes it a line. And so it does pass the horizontal line test. So that means that it's going to have an inverse. How are we going to find the inverse? We're going to replace f of x with y. So let's do that. And then we're going to switch the y with the x. So and wherever you see a y, we're going to write x. Wherever we see x, we're going to write y. And then we're going to solve for y. So we're going to subtract -4 on both sides. So we get x minus 4 is equal to 5y. And then we're going to divide by 5 on both sides. So we get x divided by 5 minus 4/5 equals to y. So the last step is to change y to f of the power of -1. So that's the symbol for inverse. And so the inverse of this function is 1/5 x minus 4/5. Okay. And so if you were to graph these, then they reflect on the line y equals x. But basically, those were just some examples of what you might see on your first exam, which will, for most of us, that next exam will be taken next week. And so if you are taking your exam next week, we wish you the best. And you can download this presentation by clicking the box up here. And so if there's any questions, please feel free to ask us. And then you can also rewatch this video. I believe they posted the YouTube channel. Or if you miss one of our previous Friday Happy Math Hours, then you guys can also go back to see those as well. And so I'm going to pass it back over. But if you have any questions, stay here. We have some tutors here that can help you. We still have a few minutes. You can ask us any questions that you might have.
Alrighty. Thank you so much to Ms. Shuka, Ms. Isasi, and Ms. Carrizales for presenting today. Remember that next week in Math 14 topic is the standard form of quadratic equations and graphing. And for Math 1324, we have the writing exponential equations into logarithmic form. And from the student success topic, also we have the degree plans with Debbie Santana and Mary Favela. Thank you so much to everyone, to the audience for coming. We hope to see you again. So thank you for all very, very interesting presentation, and thank you every presenter.